Alright, I'm at a point. I figured out another way to measure this thing, but I'm not sure the jaw is perfectly flat, so I want to be able to clamp something against there. So I figured it's about time to go ahead and do the bolts. Okay, so I'm just gonna, with the nut on it and that stuff, I need a little extra length, so I'm gonna call it right about there. It's a black rod, so what I'm gonna do to mark it is instead of a Sharpie or whatever, I'm just gonna put a little file mark on there, just so I have a shiny spot to that way I can go cut it. Alright, let's just cut it off with the cut-off wheel. This one still has enough life. There's a V cut into the end of the jaws here for holding round objects. That way I don't have to squish the threads flat. Probably blocked half of that, huh? Alright, well, I'm going to mark another one and cut a second one. Alright, showed this in another video, much more close up. Just going to whip these out. Not too worried about how clean the one end is because it's getting a nut on it, welded on. And the other end, actually, I'm going to put it in the lathe at some point. If you watch the other video, you already know this. I'm pulling up on it and using the wire wheel to pull the burr out of the end of the thread there. So. What I'm going to do is, on the lathe, because these will need to go in and out of the hole on the, you like how I quit talking when my brain gets too busy? Basically what I'm going to do is, on the end here, the last like quarter inch or so, I'm going to cut the threads off. Okay, because what happens is they need to go in and out of the hole on the, get some comments on that one, the jaw. Okay, now since I want to be able to back them all the way out of the hole, I don't want the threads damaged. Okay, so what's going to happen is if I leave just the threads like this with nothing on the end, as I clamp in parts hard and stuff like that, sooner or later these threads will get damaged, and then when I pull them out of the hole in the jaws, that's what's going to strip them, like it did, like they were stripped before. So. If I cut the threads off, then I just have this end that pushes on it. No threads there to damage. So I'm sure I'll go over that again when I do it. All right, let's whip a little welding on here. More than enough. Let those cool down and do a little grinding. And right, call it good. Clean the heads up on them here. And other than the lathe work, which you can't do until I get the compound back on, they'll be pretty much done. Almost time to change the belt. grind on this one. I already checked them in the, already put a socket to them to make sure they fit, so not a problem. Hopefully I won't get in the way too much here. Basically what I'm doing is I've got a dial indicator here, test indicator. I need a perfectly flat surface. The surface on this jaw is pretty darn smooth and nice. It's okay. If there's any bumps or anything like that in there, I want to average it out. So what I'm going to do is I'm going to put these two parallels in now. The point of the second parallel, I'm not shoving it into the corner hard. I'm leaving it off the corner a little bit there. Okay, so that I can push up against that, and this thin outside edge here will be parallel with the base of the jaw. I don't need to reference that right now. I'm setting that up for later, basically. So anyway, what I now have is this nice perfectly flat inside edge that's pushed up against the jaw there. And now I can come in here and get an indication on the test indicator there. And now when I run this thing up and down, I'll be able to see on the test indicator how far that's twisted up. Okay. So I'll show a little bit more on that. It's each increment is 1/2 thousandth, so we're about 1.5 thou off right now. So I'll have to tinker with that a little bit and find the best, you know, in the middle of the road there kind of thing. If I can't get it exactly perfect, and call it good. It's about 2 thousandths off. So I'll tweak that and come back. Okay, I figured I'll show it here real quick since it's kind of set up. I haven't tweaked it, that way you can see the discrepancy. So as I run it back down, okay. So basically I need the top to come toward me a little bit. Okay. So I got to loosen those up and do that. Let's see. Alright, I just want to make sure they're snug so I can't bump them and knock them loose. It's a little hard to get to the bottom one there. Alright, I want to leave a little tension on it. Okay, I'm going to put some tension back on it there. So let's go ahead and so that's telling me that the bottom is moving closer to me. Okay, so when I get it up here, I'm going to tap that side down a little bit. That should have rotated. Okay. Get a little closer to zero there, just because it's easier to remember where you were. Okay, so it's still getting closer to me as we go down. Now, one thing you got to watch when you're doing this, because any backlash and that stuff in the cross slide here will show up. So, you know, you want to make sure that as you crank it or tap it or whatever, you know, you're not inducing some change there from that. So I got to remember to keep track of that. Okay, so it's still coming toward me, so I might have went a little far. let's go ahead and double check, make sure they're snug. Okay. And I'm reading 2000ths right now. Two and a half. 3. So I got, oh no, still 2 and a half. It kind of wobbles back and forth a little bit from the thing. That's a 0.5 thousandths difference from top to bottom there. That's most likely close enough. I'll tweak it a little bit more, but there's no point in watching that for another 5 minutes. All right, you might be able to see the needle from there. Something I forgot to say is, you know, when I was showing how you get some deflection there. This is an old lathe. Ways are kind of worn out. You don't see the weird snowflake design from them hand shaving it and that stuff. There is a bolt over here that locks this from going this way, okay? So I've got that locked down. These are tight, okay? These are pretty snug. This deflection you're seeing in the needle there, you know, that's in the ways down here. You can see the oil squeeze and stuff like that. Problem is old machine, stuff wears a little unevenly long before I had it, stuff like that. It will get really, really tight at one end or the other, and it's kind of hard to get the adjustments set. So, you know, on older machines, you end up having to compensate for some of that stuff. So, I had to do it on here too because it was getting so tight that every time I cranked on the handle, I was having trouble getting it to go up and down. So I redid the tension on these just a little bit. There's no play in it. You know, other than what you see when I'm shaking the whole thing there. So, anyway, it's an old machine. So as you can imagine that as you start cutting steel and stuff like that, especially, the cutting forces that it takes to rip a chunk of metal off, you know, that's going to show up either in, typically as chatter, surface finish, stuff like that. So you just got to kind of deal with it and compensate with it on an old machine. And a real machinist knows how to do that. You know, I fake it. Okay. Yeah, you know what? It had to dawn on me. I may have put a little bit of bow in the parallel there. Alright, so that last pass going up induces a lot more flex because there's more drag on the for me turning the handle and that stuff. So if I get up there, and it's a 0.5 thousandths per increment, so you know, it runs up to 1, back down to 1/2. That's pretty darn close. I'm gonna call that good because that's all within a 0.5 thousandths, and most tolerances that's plenty fine. And on something this old, Alright, I just got done milling a 45-degree bevel on there because when it sits in the jaws, it dawned on me that there's a round back there. I've talked a couple times about not going up against that corner because it wouldn't sit right. Then I realized I better get rid of this corner in order to do that. So anyway, if you could see in the video there, it leaves quite a burr. I cut it with a carbide, which isn't extremely sharp. So basically I want to come back with the file and break that edge off that burr and just clean it up just a little bit there. That's a real common way to deburr the edge of aluminum. So that's hopefully I can just recut this by the time I cut the groove in there. Hopefully that'll be deep enough to cover up that, and I don't have to make another block. All right. As you can see, I've got some of the notch cut in there already. It seems to be going okay. So I still have a little bit more to cut in to get rid of the garbage I left there before, but yeah, +2 in order to get even a good bite. It really probably should be a 60-degree V, not a 45, not a 90. Should be splayed open more, you know, instead of less. But anyway, I'm going to make a few passes here. I'm moving the saddle 10 thousandths this way, and then 10 thousandths out. So that way each wall is getting cut equally. I may have to trim it up in the end. Basically what I'll do is I'll put a rod in, I'll run the 2 bolts in, see if they line up over the center of the rod, and adjust accordingly. But I'll make a couple passes here, so just so you can see, and we'll call it good. Plus I changed cutters and put a brand new cutter in that's nice and sharp. And yes, I'm standing on a stool so I can see down over it. Another 20 or 30 thousandths to get rid of that mess I made yesterday. Alright, so there's 10, and there's another 10. All it took was no, it's gonna take one more pass, another 30 thousandths. But since I'm getting close, let me put the bar in there and let's get an idea how it lines up. Oh, I'm definitely gonna want to finish on a climb cut. If you guys can see that, there's a bunch of debris in the cut. Conventional cutting, the cutter would cut up and you know, cut into the metal like this. On a climb cut, you know, when it's going down, it's climbing, you know, when I'm lifting up like that. So let me put it back to where it was and take another pass to check it. Okay, that looks like it got it. Oh man, oh, that hurts. Oh. Okay, so if I hold it in the V, I don't have the bolts. Oh man, this is too much like work. No, I don't hurt this bad at work because I don't do anything. Oh, I should have blown the chips out of those holes first. I'm gonna stick some aluminum and get it jammed into the threads there. Okay. Okay, now if you can see that, it's not near center. So basically what I can do is I can leave the carriage this way, the way it's supposed to be, and then just pull it this way and go probably, man, probably close to another, let's see, I like that, 1/16 of an inch, 1/8 of an inch, a chunk. I'm going to take this out because it'll hit the jaw going up and down. And I'm going to finish that off. I'm going to cancel this, see what happens. If I can find the button, there we go. I guess I didn't find the button. It's not perfectly centered, and that's fine because the bolts will have a tendency to push it to the back. But it's pretty darn close. I like it. It looks like it came out really even. And you know, the thing is since it's a removable aluminum jaw, you know, if I get a better, more accurate way to do it some other time, I can take it out and redo it. That sure beat the heck out of cutting the jaw for the actual attachment itself. Might have been a royal pain in the butt, but I'm glad I went ahead and did it that way. I think it'll really turn out to be worth it. So now I can turn it over and get it flat, basically, and get actually to notching some tubing, except that the day is almost done for me. We're going to a movie. Dawned on me it didn't have a very good angle from the other one, so there's the groove. Perfect.